everyone, this is our first official self-paced video for the course. So I'm going to kind of walk you through some of the aspects of this as we go as well. But today we're going to be talking about how do scientists categorize different scientific findings and claims. So there's a lot of things that people say in life, and there's a lot of things that people claim, but those are not always categorized in a scientific way as facts or maybe as theories, or in a way that is meaningful. So that's what we're going to talk about today, and how we can sort out and kind of differentiate between all of these different things. Okay, so the 4 or the 5 types that we're going to talk about today are fact, theory, law, belief, and hypothesis. And on the back side of your on your note sheet, you're going to go through and you're just going to fill in kind of the blanks as I lecture through this. And then on the back side, there'll be a practice for you to kind of practice classifying these claims. Okay, so first thing we're going to do is, what is a fact? This is probably like 99% of our vocabulary is just stating facts. Okay, so a fact is a phenomenon that's repeatedly confirmed by observation. So an example of this would be, I am wearing a gray vest today. That fact, though, is not permanent. Okay, it can change as new information, maybe through technology or just through changes of events, becomes available. So on Monday, it will no longer be a fact that I'm wearing a gray vest. Okay, and they're limited by how much an observer can actually see. So a fact would be that this wall is purple, or that it has a periodic table on it. Those are facts, okay, because we're observing it and then we're stating something that is true. Okay, a hypothesis is an explanation of one or more phenomena in nature that can be tested by observation, experiments, or both. Okay, and the key thing here is it's typically an if-then statement. So I would definitely write that on your note sheet, because most of the statements that will be you're quizzed on or on the backside of your practice sheet will be like easy to identify, because there'll be an if and then a then statement. So typically it's an answer to a research question, and they're always testable and can be confirmed. Okay, so think about a good one would be, if I drank 2 liters of water every morning, would I need to use the bathroom more often? Can I test that? I can drink water, and then I can record how many times I need to use the bathroom that day, right? That is a testable question. And a hypothesis is a prediction of how that would play out. Okay, so that's why it's typically in an if-then format. A theory is a well-substantiated explanation of some aspect of the natural world. Okay, so a theory is after a scientist has collected facts and observations, they've tested their hypothesis, they've evaluated laws, and they've brought together all of these pieces of information, then they're ready to make a theory. Okay, so it's typically built upon data and conclusion, and it's typically from many tested and repeatable experiments. It's not just something that this one-off scientist says without data to back it up. And so most things, like 99% of the things we talk about in science class, are based on theories. They're theories that scientists have. So, for example, all your body is made out of cells. So that's a theory. It's based on all of the information we have right now. We know that that's true. Or the earth is round. That's a theory. I think that's a theory. That one's a little bit trickier, but the earth is round. Based on our data, photographs, all those things, we can say the earth is round. You can't immediately see it, but based on kind of this other collection of facts, we can learn that that is true. Or let's see, what else? I'm blanking on anything else, but you get the point. The big one is like most of the things in biology that you learned, those are all theories. Okay, so when we say I have a theory, it's typically like unsubstantiated, it's not supported. That's not what we're talking about in science class. This is something that is well substantiated, it's very supported, and it's based on all of the other types of words that we're going to talk about. Okay, a law. A law is something that is a description of how something will occur under natural circumstance. So I think that I can name like 5 or 6 scientific laws right off the top of my head. There are not a ton of them. Okay, most things in science are theories, not laws. But let's see. Some laws would be like Newton's laws of physics. Okay, so an object in motion stays in motion unless a force stops it. That is a law. Things like that would be considered law. A lot of people say that gravity is a law. There's some laws when we talk about how chemistry works and how like electrons fill orbitals that are laws. But typically, we're talking about theories, not laws. Okay, and they're used to predict behavior because it will happen every single time, and it explains repeatable behavior. Okay, the last one. I throw this one in there because I think in science it's hard when we have beliefs and that those sometimes align with all the things that we're talking about and sometimes don't. Okay, so I just wanted to find this, and I want to say first off that you are allowed to have different beliefs in this class, and that we're going to talk about things that are based on substantial evidence. But it's also your job to kind of to put those together with your beliefs. And a belief is just a mental act, condition, or habit of placing trust in something. Okay, so a belief could be that girls are smarter than boys. There's not necessarily data to back up that statement. That's a belief, an assumption I have. You could say, like Mr. Bradley thinks that which is my co-teacher, thinks that that Harry Potter is the best fictional series out there. My husband thinks that every Christmas should be spent watching all 3 Lord of the Rings. Okay, I do not believe that. I do not hold that same belief. So we can disagree sometimes on beliefs, but typically in science, we're going to focus on observations, measurements, and then creating claims or theories based on those 2 things. Does that make sense? Okay. There'll be a couple practice questions here to kind of test your knowledge, give you immediate feedback, and then you'll flip over that backside and you're going to go through and just classify each of those statements as true or as each of these different types. And then there will be a key on the front board. So go up there and check your answers when you're done to make sure that you're ready before you take your mastery check. Have a good day.